Started now. Yeah, students, in this lecture, let us try to understand how to eliminate the rounding that is produced at the output of an astable multivibrator. As we have seen in the last experiment, there was a rounding. Okay, let us try to eliminate by using a diode and a resistor connected at the collector terminal of the BC547 transistor. In the last class, I was talking about the experiment, but now I will give the configuration of this transistor BC547. It is somewhat like this. So now this number is printed like BC547, something like this, and you can see three terminals here. One is emitter, as I was explaining in the last class. This is base, and the third one is collector. Okay. Now this will make the concept clear. So I will make use of the transistor here in the circuit. So last class I was explaining about how to give connections in the breadboard. Now what I do is just I will extend to that one. Just have a look at this circuit diagram, and we drawing this. This is I will take 1 kilo ohm extra diode here, and then you have 3.3K kilo ohm resistor, and you have a 33 kilo ohm resistor. Here I will connect one capacitor of 0.01 microfarads, and then a diode I will take it here. Okay. Then next, this is the transistor connection. Okay. Then again you have a 33 kilo ohm resistor followed by a capacitor, and then you have 3.3 kilo ohm resistor followed by one more 1 kilo ohm resistor. Then I will take a diode connected in this direction. Okay, this diode is simply 1N4007. Remember, this is 1N4007. As I told you, this transistor is numbered as BC547. This is an NPN transistor. Here I need to take one more transistor. Okay. Now two emitter terminals are connected together and thereby close to ground. Now the job is cross coupling. This one, and I take a jump connection over here and connect it to the base of the other transistor. So from the collector, either of the collector, as I told you, you can take the output and connect it with respect to ground to the CRO, that is cathode ray oscilloscope. Okay. Then for biasing we need to provide some 10 volts power supply. Okay. This is 0.01 microfarad. So using this connection, again, as I told you in the last class or last lecture, it will be around 2 kilohertz is the frequency of oscillation. But when experimentally we do, because of so many inaccurate valued components we are using, so it will be around between 2 and 3 kilohertz we get the result. Okay. Now what we do, we will go to the apparatus and let us look how this experiment is, that is components are connected in the breadboard, and then let us look into the output wave shape. Now you have seen that this output is somewhat like this, say little curved like this, and then you can see this type of waveform we got. Then this is the time axis. Okay, this curved shape we are calling it as rounding. Okay, now we can eliminate this one and make it a straight rectangle like this. Okay, now let us go to the apparatus. Particular circuit, come little closer here, take little closer. So I can show you here. This is a silver. There is a silver line here. Okay. Now that is going to the collector of the transistor. You have to be careful in connecting these diodes. Okay, with the negative terminal connected to the collector of each transistor. Okay. The role of this job is here. Usually in the other circuit in the last lecture, what we have seen, the current from the transistor goes to the capacitor. The collector current which was flowing from the resistor will go to the capacitor for charging purpose. So that rounding was there. Now what we are doing now, if you connect a diode like this, okay, now this current is not taken from the collector, instead it is taken from somewhere else. That is, other resistor is there in the circuit diagram, you can see. Okay, followed by that one, that is 2.2 kilo ohms. Therefore, the loss that we have seen because of the charging of the capacitor, now that is not possible in this case because of the reverse bias diode. Therefore, we are getting a waveform like this, a square wave. This curved, okay, that is rounding, is now eliminated, as you can see here. Now on taking the readings, okay, observations, I mean to say, here the time period and frequency, if I calculate from this figure, okay, what I can show you here is in the figure, okay, just take to the left side, right side, little, right, now here I am getting on time 2 boxes and off time 2 boxes, and this is multiplied to 0.1 milliseconds on the CRO screen. Okay, here 0.1, and the scale, this is times per division I am getting in milliseconds, 0.1 milliseconds. So these 2 boxes, okay, on the CRO screen multiplied by 0.1 milliseconds, I will get 0.2 milliseconds. So here similarly off time is 0.2 milliseconds. On adding these two, I will get total time as 0.4 milliseconds. Okay, then if I calculate the frequency as a reciprocal of time, that is f is equal to 1 by t, then is equal to 1 by 5. Calculate this will be 1 by 4 milliseconds, turns out to be 2.5 kilohertz. Okay, so we understand this one. I was telling that the frequency will be ranging from 2 to 3 kilohertz, so I am getting 2.5 for this. Next, if I calculate the amplitude, we have applied 10 volts here. Exactly on the CRO screen, I can read 2 boxes here. Okay, and volts per division is at 5 here, this one. So at 5. Okay, therefore I wrote here 2 boxes, that is 2 volts. Okay, multiplied by 5 volts per division. So 5 multiplied by 2, I am getting 10 volts. Okay, so with this experiment, what we have seen is using one diode and one extra resistor, you can eliminate the rounding that was seen in the last experiment.